Hi, I'm Gabriele Bartolini. I'm the head of support for second quadrant and also a member of the PostgreSQL community. I will be talking here today at PGDay.IT 2018 about declarative partitioning in PostgreSQL from version 10 and also on PostgreSQL 11. So is partitioning good enough in Postgres? Well, some people, depends. It depends on, what do you think about this glass? Is it half full or half empty? I'm optimistic. So to me, it's half full. Okay, but we'll see that PostgreSQL has a lot to do in regards to partitioning. Okay, some people might say it's half empty, and there are reasons for that. Okay, and I hope that by the end of this talk, you will be able to at least start forming an opinion and start benchmarking PostgreSQL 11. Okay. So thanks for being here. My name is Gabriele Bartolini, and today I will be talking about declarative data partitioning with PostgreSQL at PGDay, Italy. For those of you that don't know me, I've been working with open source since 1995, and first time I used Postgres, it was in '97. Then I was a MySQL user, so I've been using MySQL for a few years, and then in 2000 I switched to PostgreSQL, and I never thought about going back to MySQL again. Okay, I was even in MySQL 3.23 documentation because of the software I was writing at that time. Excuse my cough, but I've got a start of line infection, so I better be careful. I'm one of the founders of the Italian PostgreSQL Users Group, as well as PostgreSQL Europe, which is a non-profit organization that organizes every year the PostgreSQL European Conference, this year in Lisbon. And I've been part of second quadrant since the start. This year we celebrated the 10th year anniversary, and I'm head of global support. So I'm in charge of the service that keeps up the PostgreSQL databases for many companies all around the world. I'm also a fan of Lean and DevOps practices. Okay, for those of you that don't know what DevOps is, I invite you to go and search Google for some material. It's about a culture that improves, in my opinion, the processes at work in IT. Okay. So I don't know how many of you are familiar with partitioning already. Okay. So anyway, in this first part, I will give you a short introduction about what partitioning is and what it tries to solve, what problems it tries to solve. So, and we will use throughout this presentation a very simple use case of table containing transactions, which we call facts. Okay, a generic fact. In this, it could be a sales transaction, it could be an HTTP request, it could be anything. And for those of you who are familiar with data warehousing, you might notice, a similar term. Transactions will contain information about when that event happened, what that involved, and who requested that, as well as some measures. So for example, we will have the day, the item of the transaction, the customer who bought that, for example, the quantity, the price, and other measures. Excuse me. So in a very simplified model, we will have three tables. We will have the so-called dimensions, items, and customers, and then a generic fact table that, as I said, could be sales, could be requests, and so on. This is the SQL we could use to represent this table. So a very simple one. So I didn't use primary key, just to keep it simple. So we have a column called fact day, which is a date. Then a customer ID that references the customer's table. The item ID that references the items table. The quantity, the price, and as I said, other measures. We could have many, okay? So thinking of a single table, this is how it is, how it looks. Okay, we have fact day, customer item, quantity, and so on. We have one big, large table with, the associated indexes. So, for example, if we add one item here, that operation also needs to update the index. If we update a row, we also update the index. If we delete rows, we need to update the indexes. And the indexes span over, the whole range of time that we store in the table. So even if I update or insert only at the end of the table, I'm also influenced by the older data. So if this kind of scenario over time becomes slower, and slower. So it doesn't scale. That's the terminology, okay? So that's why we decided, some database experts decided to introduce the concept of partitioning, which is a logical and physical modeling technique that basically splits data in different segments, each one non-overlapping segments, each one called partition. Okay, so the intersection must be empty between these tables. Okay. There's also, a broader concept. If we think about partitioning, we also have to think about another one that is less common, which is vertical partition. So in vertical partitioning, we actually take a table and we extract some columns from the table and create another table based on the primary key. Okay? This is the most common method, which is horizontal partitioning, and we cut across. Okay, so based on values of some columns, we take some rows and we put them in different tables. So vertical partitioning is mainly used in data warehousing, so big data. Now it's called big data. I still like to call it data warehousing, but I'm old school. And it's usually important when you have tables with many columns. Okay, so if you have hundreds of columns and you usually access just a few of them, vertical partitioning might help you in terms of performance. Okay. Some databases, like for example Greenplum, that we were here before, they actually have the columnar storage or column-oriented storage for that. Okay? But vertical partitioning is not very common. And that's why, for example, every time we mention partitioning, we usually refer to horizontal partitioning. So horizontal partitioning is also useful in OLTP, so transactional databases. And the idea is to divide rows by a certain criteria. So from now on in this presentation, when I say partitioning, we will refer to horizontal partitioning. So let's go back to the same example. So we've got the same fact table that we have actually divided per year in this example. Okay? So 2018 is a different table with its own set of indexes. 2017 another one, 16 another one, 15 another. Okay? So when I insert a fact regarding today, I do not touch these tables. I just touch the 2018. So I work on this set of indexes only. Okay. These tables might as well be read-only tables. Okay. So, just by looking at this slide, you can already, think of some benefits from using partitioning in your databases. So the concept of divided impera, that we all like, because thinking in smaller sizes helps us solve bigger problems. Okay. We have smaller tables, so there's not anymore the monolithic table we had before. So think about a vacuum operation running on a very, very big table. Okay. We have smaller indexes. Therefore, if you think about, let's already think about sequential scans. If you have a data warehousing query, for example, an aggregate query that has to read a certain percentage of your table, PostgreSQL starts a sequential scan. So doing a sequential scan of a table that contains data spanning from 2015 to 2018 takes longer than a sequential scan on a table that contains only 1 year of data. That's common sense. So it's also easier to maintain because vacuum, for example, can optimize the work, because if a table contains data from 2016, it's not been updated, so there's no need to run vacuum on those records anymore. Also, delete operations are easier because if I need to remove all data for 2015, before in a single table I had to do a delete operation which generate dead tuples in the database which need to be vacuumed. Okay? In this case, we simply drop the table containing the 2015 records, for example. Also, we have finer control on storage thanks to table spaces. For example, I could put the current table on a very fast disk, whereas all tables on cheap disks, because they, for example, used less frequently. Excuse me, but it's not my fault. The common strategies for partitioning are two usually. Okay, one is range, and usually on the time dimension. Think about logs. Okay. Think about transactions. Think about invoices. Purchases, and hash. For example, think about customers. We can suppose that we can store customer data in different partitions based on a hash of the user ID, for example. And partitioning can also be multi-level. We call them sub-partitions. So, for example, we could have a fact table that is partitioned by time, and then sub-partitioned by a hash on customer ID. So this is the example, the model we could generate. So the master table is split based on time, and then each partition we have, for example, in this case, 8 partitions based on a hash on the customer ID. The general idea behind this partitioning method is that data is uniformly distributed across all these partitions. Because, for example, if you have a customer that does 95% of the transactions and it ends up in this partition, this will be heavily penalized. The concept is called skewing of the skewing factor of partitions. So theoretically, they should all be have the same amount of records. These partitions for better performance. So this is a general overview of partitioning. Let's try and dive deep into how Postgres allows us to manage partitioning. I assume that most of you are in this scenario. That's why I still put it. Even though now we are talking about PostgreSQL 10 being the latest stable release, I think that most of you still fit in this range. Am I right? Is anyone using Postgres 10? Okay, good. Well, as I said, I've been working on Postgres way before 8.1. So I still remember when the first partitioning technique came into Postgres. Okay, it was fantastic for performance, but we'll see all the issues that we had. Okay, so with Postgres, until 9.6, there's pretty much the same technology. From 10, there's the introduction of declarative partitioning, which is the future. Okay. PostgreSQL until 10, even though it still uses inheritance, okay, but before, inheritance was the only way we could implement a model partitioning in Postgres. It was not declarative, so there was no partition by construct. The general concept is that we have a master table, which I usually call it abstract from object-oriented programming, because it contains no data. Okay, it's a table that must not contain any data. So it just defines the model of the class of the table. And by the way, it's a class because of inheritance in Postgres. Okay. And partitions are the child tables that inherit from the master, inherit the same model. And through check constraints, we make sure that data that is in a partition has specific values for the partitioning criteria. Okay. with an example, I think everything will be clear. Okay. So this is the master table, as you know, I presented before. Then we create a partition, like the child table, this way. So follow me. We create a table, a concrete table, with this convention. You could use another convention. Okay? I put Y before the year and M before the month. Also because if I order the table in alphabetical order, that they're all also in chronological order this way. This is the check constraint that defines the values for the partition. I say fact day must be between the 1st of June and the 1st of July, not inclusive. Okay? So all days in June. And we inherit, I specify an inheritance relationship between this table and the facts table. So it's a workaround, okay, but it works. It's not declarative. It's not how other databases do it, but it works. And that's why for many years nobody has worked on declarative partitioning. Because from a performance point of view, scalability was okay. It basically works this way. If I perform an operation, a select operation on the master table, it's automatically sent to all the child tables, okay, in a linear way, in a sequential way. Okay? There's an optimization. Probably you have seen this option, it's constraint exclusion, which is, again, a linear algorithm that prunes at planning time those partitions that do not match the search criteria of the where condition. Okay? If I don't have a where condition, it's like a union all of all these tables. If I can perform updates on the master table that are rerouted to the child tables, but moving across partitions, moving records across partitions is not allowed. Okay? So if I want to change a date of a fact from June to July, that's not possible. I need to remove that record and insert another one in the other partition. Insert, that's the problem, that's the main problem. Insert on the master fact table, insert rows in the master table. It's not routed on the child table. Okay, so that's why for many years we've had to write a routing trigger. Okay, unless we want to directly insert records in the partitions. However, from maintenance point of view, the situation was has always been good. Because, as I said, with partitions I can use drop table instead of delete to prune old data. And that's an instantaneous operation. Whereas a delete operation requires also rollback. That's why we have to write information on old files, etc. So this is a routing trigger, just so that you know. It's a before insert trigger. I know it's written small, but you'll be able to read it in the slides. It's essentially a trigger function that detects the date I want to use for the insert and routes the insert operation in the appropriate table. Then returns null so that the record is not inserted in the master table. This is old school. Okay? It's a bit it's a bit old. It's, you know, from a performance point of view, there's an impact. Okay, but that's what we've done for, you know, many years. Now, PostgreSQL 10. Finally, we have declarative partitioning. But most importantly, we have the framework for declarative partitioning. And that's it. Because, yeah, you can't do much on Postgres 10, unfortunately. Yeah, you can start already migrating your models in the new one, but from a performance point of view, you have no benefits at all. Okay? So we have a new construct for the create table command, which is partition by. So with partition by, you can define a master table. Then with partition of, you define a partition, okay, the former child table. If a table contains both, that's a sub-partition. Okay, you can define sub-partitioning by using both of them. The available partitioning methods in Postgres 10 are by range and list. There's also attach partition for the altered table and detach partition for altered table. So you can do it at runtime, you know? You can create tables and then associate them at a later time to a partitioning schema. This is how you create a master table that we can call partitioned table, okay? Same example, you just add partition by range fact day. So you say that, you know, you use that column to partition the whole logical table. And this is how you create a concrete table, you know, a partition. Using partition of. Okay? And you define the values, this is the range, and 2 is not inclusive. There are, of course, some limitations, as I was mentioning before. If you execute an update on the partitioned table, it works like it used to work before, but if you have to move a row across 2 partitions, it doesn't work, you get an error. Also, it's not possible to prune partitions at runtime. So it was not possible before as well. We were pruning partition at planning, during, you know, planning time. So if you use prepared statements, you won't see any benefits. Okay, you won't see any clear benefit on using partition. Actually, you could be penalized in some cases because all prepared statements will reuse the same plan. Because constraint exclusion is, as I said, is a linear algorithm that is performed at planning time. Prepared statements, they reuse the same plan. Okay? So you will need to benchmark your applications anyway, as you always need to. But it's the same technology that we had in 8.1, still in 10, for this kind of queries. There's also impact on joins, because joins are executed at runtime, so partitions do not work well still in 10. Okay? There's no support for foreign keys. So if you want to add a foreign key in a partition table, you need to add that to each of the partitions. Okay? It's a manual operation. You can do it, but you can't define them on the master one, on the master table. there's no default partition. So if you insert a record in the master table that does not belong to any partition, you get an error. Okay? So, and it's not possible to automatically create new partitions based on the value of the new record. Okay? This is a limitation. Also, there's a difference between creating indexes on the master table and the child table. So if you want indexes, you need to create them in each of the partitions. So it's from a usability point of view, that's not easy. Also, from a maintenance point of view, that's not easy either, because think about having hundreds of partitions, and you need to check that all of them have the same indexes, have the same constraint, etc. Okay? But as I said, 10 is important because it opens a new era for Postgres. Okay? So let's get to the at least positive message, of partitioning Postgres, which is version 11. Okay, we start to see, finally a good solution ahead. You have to apologize me, but my voice is, ending. So this is the list of features that Postgres 11 has introduced. As you can see, there are many. Okay, let's go through each of them. There's hash partitioning, so we can partition by hash. So for example, we can say we've got 8 partitions. You perform a hash on the customer ID, and in this partition, you put the records with remainder of the modulus operation of 1 or 0. So if we have 8 partitions, we have modulus remainder of modulus 0, 1 to 7. Okay? We can create indexes on the master table. So if we create an index on the master, it's already inherited by all the partitions. Thanks to the work that my colleague Alvaro did, we have triggers on partitions. So thanks to that, now we have foreign key support on partition tables. So that means that I can define a foreign key relationship on the master table for the dimensions, for example. We can't yet do the other way around, but I think it will be something we'll see in the future. We also can create local unique indexes. So we can define unique indexes on the partition table, on the master, but that actually are created in the partitions. As long as the index is a superset of the partitioning criteria, which means that we need to add in the unique index the column we used for partition. Updates can finally move records across partitions. Okay, there are still some caveats, especially in high concurrent situations, but from a functionality point of view, we can do it. So this is important because thanks also to default partition support, which it's, in my view, it's not optimal, but it's good enough for lots of cases. I was saying, even though it's not perfect, I think with those features, we have pretty much completed the features of the gamma of features that partitioning can do in Postgres for selects, updates, deletes, and inserts. Okay. So yeah, one important thing I forgot to mention before is that inserts now are automatically routed to the partitions. Okay, I forgot to mention that before. Okay, it's important. That's why yeah. Okay, so PostgreSQL 11, as I said, completes this gamma of features for Postgres. But let's get to the the point that is not finished yet. Okay, we still need to do a lot of work in terms of performance. Okay, but an important one has been done with this option, which is by default set to on, which is enable partition pruning just for selects at the moment. So basically, PostgreSQL can now prune partitions at runtime for selects. There's work to be done for updates and deletes, but right now for selects, if you perform a query using prepared statements, now there's a two. Basically, the algorithm is not linear anymore; it's a binary search algorithm for constraint exclusion. These allowed our developers, and one of them, in this case, is my colleague from New Zealand, David Rowley. They implemented this two-phase algorithm that is executed at runtime. In the initialization phase, we examine the parameters of the query. In the second phase, they examine, for example, nested loops or subqueries. So you will see that performance gains are relevant, are meaningful in this case. There are also two more options that have been added, but they are by default disabled at the moment because of their impact on CPU, but we can enable them before performing a query. One is partition-wise join. Basically, partition-wise allows PostgreSQL to push down joins at partitioned tables, so on the masters, to the below partitions if the partitioning criteria match. Okay, it's a bit complex, but in some cases it pays off. Okay, but not on all cases. The other one is partition-wise aggregate. That basically aggregate operations can be pushed down on partitions first and then aggregated after. Okay. I just put them that they're not easy cases to demonstrate in talk like this. But if you have time, maybe search for some blog articles and do some research. So this is how you can define referential integrity from the master table. It's very easy. Partition by range is the same. This is foreign keys in action. You can insert a value of a customer that does not exist on the master table and you get an error. Okay. This is how you create indexes of all the partitions, just on the partitioned table, in fact, and it's narrative, not all of them. This is how you define the default partition. So in case you insert a record that doesn't belong to any other partition, it ends up here. It's not, it's got some use cases. It's not perfect because there's a limitation. Once you add a default partition, you cannot add any more partitions. Okay? It means you need to detach the default partition, create a new one, move the records, and reattach. So there's a bit of maintenance, but some people might find it useful. This is how you define subpartitions with hash. The diagram I showed before. You partition, this is the month of June, and then based on customer ID. And this is how you create the subpartitions. This is the first one. You will have 8 of them, with the last one called P7, with remainder 7, using modules. So, as I said, Postgres 11 is definitely a step forward. It will solve many problems, so I'm sure that lots of users will find it useful. But for very high-end users, especially with lots of partitions, it won't be enough yet. So there are some features that I'm still missing, as I was saying, pruning for updates or deletes, better creation of partitions. So for example, if I don't have to create all the partitions myself. I would like to say partition by fact day, starting from this to now by 1 month. And all partitions will be created, but we can work on that. Create also foreign keys as where partitions are the target, so inbound foreign keys. Concurrent detach and attach of partitions. And as I was saying, one thing is if you have partitions by year or by month. One thing is if you have partitions by hour with 10,000 of partitions. That's, from a performance point of view, there's still a lot of work to do. This is an example by my colleague Tomasz. It shows that if you have 1 year of data, the partitioned model for TPC-H, which is the data warehousing benchmark, query 1, performs better, but as you see, as the number of partitions grow, performance actually gets worse than having one single table. This is the work that David did for 11, the prepared statements, the pruning at runtime. If you can see that for prepared statements, 11, which is the green one, almost is the same as having one single table, which is the best scenario for prepared statements. So it means if you have Java applications or Python applications that use prepared statements, you will see a lot of benefit from 11. However, as I was saying, there's still a lot of work to be done. This is current work in progress by some of my colleagues at Second Quadrant. We already have a patch for this case, which will probably enter Postgres 12. And this is Postgres 11. We can reach almost, less than half the number of transactions of a single table. With Postgres 11, the patch that we are proposing, it's almost the same. This is another case of with 10,000 partitions. This is Postgres 11. This is the green. So it's not that it doesn't exist. So performance is, as you can see, is bad. But we already have a patch that will be in Postgres 12 for this case. So as I was saying, there's also more stuff you can do to treat your environments. You can use, I haven't touched, for example, optimizations on table spaces. on parallelism, you can use parallel, queries. You can have foreign data wrappers. So a partition can actually be a foreign table on another server. So there's a lot you can do thanks to Postgres. You can also use block range indexes, which simulate partitions at index level. So, there's a lot. So, as I was always saying, support is still not optimal, but the progress we've done in 11 is massive. So, as I was saying, to me, as an optimistic person, the future is bright. Okay? If we keep developing and improving Postgres as we've done for Postgres 11, Postgres 12 will already be a major improvement, especially for performance. So yeah, sorry for background. I think the clapping is.
We don't have time for questions now, but I'm sure that Gabriele is going to be happy to answer any questions during the coffee break. So thanks again, Gabriele, for the talk. Okay, one question.
Primary index, Postgres 13.
Okay, no, you can have primary indexes. Okay.
On main table.
But hang on. Let me. Yeah, you can create primary keys on the partition table. Yeah, but the use case is not. It's not useful. There's no particular use case yet until you can, reference the partition table. Yeah, you can create unique indexes. So they're only local. So no. On the global primary keys are not yet implemented. Yeah, sorry, you can create primary keys on the partition table, but of course they're only enforced locally, which is not used. Yeah, correct.
Knowing where the road is, you can do that.
That's why unique indexes need to be a superset of the partitioning procedure. Okay, so you always need to have the partitioning criteria so that you can find records in a faster way. Okay. But you can define primary keys, but they're enforced only locally. So you can actually have two with the same values in the whole partition. Yeah. Partition is good. No worries. Thank you. Yeah, my colleague Alvaro is trying to work on this stuff. Okay, Alvaro Herrera is the guy from Chile. He's a member of the community and he's developed trigger support, foreign key support, and index support for this. Yeah. He told me it's feasible. I spoke with him, and if we find funds for developing that, I think it's just a matter of time. Yeah. It's not easy. It's tricky, but I think he already has a plan for that. That's what he told us. Yeah. Thank you.